All right, derivatives of inverse functions. We're going to walk through it. This feels complicated to get to the final answer. I think once we get there, you'll be okay, but man, it's a lot of steps to get there. So given f of x equals 2x plus 5, let's graph f of x. So this is just good old graphing mx plus b. 1, 2, 3, 4, 5. Slope of 2. And let's label that f of x. Now, do you know if it's a one-to-one function? Have you heard that terminology before? Does that mean anything to you? It's okay if it doesn't. Okay, so a one-to-one function, sometimes abbreviated as just 1-1, one-to-one. Let's back up and let's talk about functions in general. You remember this kind of picture? 1, 2, and 3 are the inputs, 4 and 5 are the outputs. Button 1 and button 2 go to 4, button 3 goes to 5. Is that a function? Do you know what you're going to get when you push the input button? Does each input go to exactly one output? Each input goes to exactly one output. So that is a function. What's not a function is when you hit a button and you don't know what you're going to get. Like you hit button 1 and you get 4 or 5 or 4 and 5. That's not a functioning. Think about vending machines. If you push button 1, are you getting a Coke or Dr. Pepper or both? I mean, it's a bonus if you get both, but that's not a functioning vending machine. So that's not a function. A one-to-one function means it's mapped 1-to-1. It means you can go backwards, is how it means. It means if you're walking around with a Coke, I know you push button 1 to get that. If you're walking around with a Dr. Pepper, I know you push button 2 to get that. If you're walking around with a Sprite, I know you push button 3 to get that. As opposed to this first function over here, if you're walking around with a Coke, I don't know which button you pushed. You might have pushed button 1, you might have pushed button 2. I don't know. Think about the vending machines that only have water in them. Like, that's not a one-to-one function. If someone walks away from that vending machine with the water, you don't know what button they pushed. Like, who knows? So one-to-one function means, basically it means you can go backwards. And thinking backwards is an inverse. So its inverse is a function. That's what we like about one-to-one functions. You can go backwards and still have a function. The point 17 lies on F. Let's label that point. So 1, 2, 3, 4, 5, 6, 7. Actually, let's not label it. Let's just make it a big dot because we're going to put more stuff on this graph. Write this point in function notation. Basically, this question has been on a previous test, right? If 17 is on the graph, what does that mean in terms of function notation? F of what equals what? F of 1 equals 7. 1's the x, 7's the y. Find f prime of x. Well, this is an easy one. The derivative of 2x plus 5 is 2. Evaluate f prime at the point 1, 7. This throws some people off. If f prime is 2, what's f prime at 1? 2. The slope is 2. Look at the picture. The line has a slope of 2, so its derivative anywhere is 2. Find the inverse. If you don't remember, that means switch x and y and solve for y. So x equals 2y plus 5. So if we move things around, x minus 5 equals 2y, y equals 1/2 x minus 5/2. Is f inverse a one-to-one function? You may not know yet, but the answer is yes. Because, how would you know? Because f was 1-to-1. That's part of what it means to be a one-to-one function, is if the function's an inverse, if it's a one-to-one function, then the inverse is also a function. Okay, can one of you tell me what this means? There's a whole lot of little marks there. What's this asking you to find? Good, it's the derivative of the inverse. So part of calculus all year long is just being able to understand what they're asking. The derivative of the inverse. What's the derivative of the inverse? 1/2. And I guess if we want to use the proper notation, the derivative of the inverse is 1/2. This next point is easy, but man, it's so important when we get to doing these problems. What point on the inverse corresponds to the point 1, 7 that lies on f? So inverses mean switch x and y. So if 1, 7 is on f, then what's on the inverse? 7, 1. Switch x and y. Write this point in function notation. So f inverse of 7 equals 1. In fact, let's put that on the graph. Actually, I think we were supposed to graph the inverse. What was it? 1/2 x minus 5/2. That's kind of annoying to graph because you got to go down 2.5. And then the slope is up 1 over 2. And you're constantly at the halfway marker when you do up 1 over 2. Kind of annoying. And there's those sort of corresponding points. 1, 7 is on f. 7, 1 is on the inverse. You might remember that the inverse is a copy across the line y equals x. So if we folded this on the line y equals x, it would copy onto itself because x and y are switched. Back to part I. Evaluate the derivative of the inverse. Derivative of the inverse at the point on the inverse that you found in H. Well, H was at 7, 1. So I want the derivative of the inverse when x is 7. How did you know it was 1/2? Because it's the slope, and if we're doing a line, the slope's always the same. So the slope is 1/2, which means the derivative is 1/2. Okay, now here's the big aha moment that is probably not quite aha for you yet, but question J, what do you notice about your answers to D and I? There's I, where'd D go? D was way up here. So what do you notice about your answers to D and I? Say it louder, Emily. Wait, who said it? Somebody said it. They're reciprocals. Remember that derivative is dy dx. So it makes sense that if you switch x and y, it would flip it over. Another way to say it is that the derivative of the inverse at 7 is 1 over the derivative, not at 7, but at 1. Because 7, 1, 1, 7 did a little bit of trading places there. We're headed towards something with that inverse thing, with that switch in x and y, with the reciprocal. Is f a one-to-one function? This one's tricky. Like, I don't know. I mean, I know what a cube generally looks like. But is that a one-to-one function? We're going to just kind of pass on this and just say yes for now. Actually, how can you tell? I'll show you how we can tell. What's its derivative? What's the derivative of this function? I need that anyway in a minute.
3x squared plus 3.
Good, 3x squared plus 3. 3x squared plus 3 is always positive. Right? Because if you square something and then add 3 to it, it's always going to be positive. And if f prime is always positive, then f is always, think about what this means. If the slope is always positive, what does that mean the graph is always doing? Up. We'll use a more fancy word than up, but yes, up is what it means. F is always increasing. That's a little bit beyond where we want to go for now, so if that doesn't make sense, then fine. Point B. There is a point on F in which the y-coordinate is 9. What is the x-coordinate at this point? Write this point in function notation. Well, if the y-coordinate is 9, I can go ahead and put the 9 out there. Then I need to figure out what x value made that happen. This is sort of the annoying part of this lesson because there's no way to do that algebraically. It's just guess and check. But if we make you guess and check, it's not going to be a hard number. So if I plug in 0, I don't get 9. If I plug in 1, I get 1 plus 3 minus 5. That's not 9. Plug in 1, I get negative 1. If I plug in 2, I get 8 plus 6 minus 5. There we go. So when x is 2, y is 9. What point on the inverse, again, got to read carefully here, what point on the inverse corresponds to the point you found in B? Well, the point you found in B was 2, 9. That lies on F. Oops, kind of all that goes together. So 2, 9 lies on F. What's the corresponding point on the inverse? 9, 2. Switch X and Y. Write this point in function notation. Well, that means F inverse at 9 equals 2. Okay, here comes the tricky part. Find, look at all these pieces, the derivative of the inverse at 9. You got to understand all those pieces there. Find the derivative of the inverse at 9 without finding a function for the inverse. Well, we said something about reciprocal earlier. So I'll spell it all out in words. The derivative of the inverse at 9 is the reciprocal of the derivative of what? Of F. Good. At 2. Very nice. It's the XY is switching thing. So if I switch the points, the XY switch, but dy dx also switches. So let's see if we can write this in mathy words instead of English words. Reciprocal, so 1 over derivative of F, so F prime, at 2. I like making a table for this to try to keep all my information straight here. So the point on the original was 2, 9, which means the point on the inverse is 9, 2. And if I can find the derivative of F at 2, then I'll flip it over to get the derivative of the inverse at 9. Does that make sense? There's just a whole lot of words that get confusing here. So F prime, we already found that. That was 3x squared plus 3. If we evaluate that at 2, three times 2 squared plus 3. 4 times 3 is 12, plus 3 is 15. So the derivative of F at 2 is 15. So what is the derivative of the inverse at 9? 1/15. So find the derivative at the original, flip it over, but then make sure you're using the right corresponding point. Can you write a rule for finding the derivative of the inverse of a function without actually finding the inverse? Well, this is what we just did. We said it was 1 over the derivative of the original let's see, if A is the x coordinate for the inverse, this is where I like to write my table here. So A is the x coordinate of the inverse, then makes it the y coordinate of the original. And I kind of don't like this question because I don't have a letter, right? I need this, let's just use B, but they didn't tell me that. So be careful about who's x and who's y. Maybe working some will help. We're going to hopefully do 1 and 3. We'll see. Answers to this are already posted. You may have noticed already that the back has an optional review on it. Let's mark some out to start with. Mark out 7 and 9 on the front side. And on the back, I forget which ones I asked you to mark out. But if you look online, you can see the answers. I'm pretty sure all the evens are marked out on the back. But this is optional. 3 things will we do on test day. That's what makes this optional, because there's 4 assignments including this. So however you want to phrase it, optional. Let's do number 1. For the problems below, and I don't really like these directions, but I made the test directions match them. So when we get used to these, we'll be okay. For the problems below, find the derivative of the inverse for the function at the specified value of x. No calculators. Okay, so let's set up the table again. So x, y, y prime for f and the inverse. And what we're aiming for, start at the end here. What we're looking for is that, the derivative of the inverse. And we know it's reciprocals with the derivative of the original. The trick is the x and y business. Now here's why I don't like this worksheet. F of x equals x cubed plus 2x minus 1 at x equals 2. But when it says at x equals 2, if we read the directions, find the derivative of the inverse at the specified value of x. That means that this x, is that the x for the original or for the inverse? The inverse. So when you just read the instructions, it sure looks like that x goes with this f. But that x is for the inverse. And if it's the x for the inverse, it's the y for the original. Because the xy switch thing. So that means it's the y for the original. And now we need to figure out what the x for the original is. Oh, another game of guess and check. Sometimes you can solve them, sometimes you're guessing and checking. Anybody got it figured out yet? It's 1. 1 plus 2 minus 1 would get me back to 2. So I need to find the derivative of f at 1 and then flip it over. F prime would be 3x squared plus 2. And if I evaluate that at 1, what do I get? 5. So that's the derivative of f at 1, which means the derivative of the inverse at 2 is 1/5. And that's the answer. Yes, you're like, and that's it, right? We're done. Yes. So like, what you're finding isn't hard. It's just take a derivative, plug in the x, but you have to be super careful about the x for what? The x for the original, the x for the inverse. What's it giving me? The x for the original, the x for the inverse. Find what you need, flip it over. It's just keeping track of x and y that's the hardest part, I think.
If x equals 2 f of x, then why is it at x in the first one?
Okay, that's the confusing part. This sure looks like x is 2 for f. But if you read the directions, they say the specified value of x for the derivative of f inverse.
Okay.
So you're right, and that's one reason I don't like this worksheet. It's very misleading to give you f and then right after that say x equals 2. But that x equals 2 is for the inverse. And so we can get number 3 set up. We won't be able to finish it, but let's see. So at x equals 1/2. 1/2, is that the x for the original or the x for the inverse? The inverse. So what does that mean about the original? It's the y. And so that means 1/2 equals sine of x. Trig. What angle has a sine of 1/2? Pi over 6. So find the derivative, flip it over, you'll have your answer. Alright, so it's only 7 more problems. 6 more problems. But yeah, they're kind of tricky. It's just a matter of keeping track with what you know, what's given, who's x, who's y, who do I flip. That's why you got to practice them. They're not hard, but man, you got to practice them to get the hang of what you know and what you're finding. Again, tomorrow we don't have anything new, so I'll answer questions from this worksheet. I'll answer some from the review. We'll have warm-ups that are also test-inspired. Everything's already in Schoology, so you can start studying now and be mostly prepared tomorrow and finish it up tomorrow.